All right. Hello and welcome to today's Plumbers of Data Science episode. Today, something a bit different. Today, we're not going to do a case study. Today, we're going to do a computer build. And I have been thinking about a computer build for some time. I'm I would say it's quite important for anyone looking into machine learning, looking into data engineering, so using tools or trying to learn tools with like Spark, Kafka, um, and so on, and Hadoop, to actually have a system where you can play around with, and where you can set up the tools, just run them, develop some code, and yeah, do some development. And I have done two builds. I have done one build. This is let's say a budget build. It's a sub $1,000 build. It's around $900. Of course, this is not super cheap. It's not a budget like a $300 build, but it doesn't really make sense to you need to invest a bit of money, especially if you start from zero and don't have some parts over from other builds. Yeah. Then if you can spend a bit more money, I have also a upgrade to that build that we're going to talk about in a second. That is around $1,500. Yeah. All right, let's jump right in. I'm going to go over the build and explain you why I would choose these components and why I would choose these updates. So here we are. Okay, so what I have been using here is PC Part Picker. PC Part Picker is a quite nice tool where you can easily select hardware for your PC that you're going to build, and so you also have the prices. You can work with prices, and it selects prices from different platforms, and you can easily get together a build. It calculates how much watts you are using and if everything is compatible together. Yeah, and you can share this. So I'm going to share the permalink to those two builds in the description of this video, and then we can discuss this stuff. Yeah. So I would say let's go over this in this order. First thing, you need a CPU build, and for everything that you are going to do today, I would say a something with more than 6 cores. So everything that is related to Intel and is in a price range that you can afford if you're building a cheaper system is basically useless. So don't go for E5 processors. AMD has a great range of of CPUs, especially the Ryzen 5 2600 here. This is a 6-core processor with hyperthreading, so it has basically 12 cores. And this is something that I think is very, very useful. So it doesn't have the highest clock speed, 3.4 gigahertz, but I think this is quite nice. So it has a decent clock speed. It has 12 cores. You don't get that stuff from Intel at that price range here, $160. So this is a good value CPU. Where you want to or why you want to get a decent core, a decent amount of cores is let's say you're doing machine learning, you're doing some training, you want to do some stuff parallel, and then you need a few cores. You need hyperthreading, and to gain a bit of speed. So you would gain more speed from more processors than going to 4 gigahertz or something. Yeah, if you're looking for data engineering wise, this is also the cores are relevant, because you want to install many tools, or you want to run a few tools in parallel. You want to run, for instance, if you want to build a pipeline, with Kafka, Spark, and let's say Hadoop. So you are installing Kafka, you're running Kafka. Let's say in a Docker system, you're running Kafka, you're running Spark, and then you're running a how were the instances from Cloudera called? I always forget. So the basically the builds where you can just download the whole thing and run a cluster in one instance, and just test the whole thing just for playing around. Oh man, I can't remember. How were those things called? Doesn't matter. You get it. So you need a decent amount of course. Of course, that's more valuable than a bit more speed. Another thing, I would always add a good CPU cooler, because as most of the people, you are going to do some overclocking for sure. So start and get a cheap cooler. This is not, you don't need to go for water cooling. Just something like this, Cooler Master Hyper 212 Evo. It's around $25. Then a motherboard. I was selecting the MSI thing, because it has a decent, it has a new chipset. It has the B450 chipset. It supports high memory clock speeds, but it's not that super important for this case. It's an ATX. It has Wi-Fi, so if you don't want to do cable stuff, you can use the Wi-Fi, and it has a slot for these new SSDs, the M2 SSDs. So this is of course, it has some color RGB stuff, but don't mind this. So this is a decent board from a decent vendor, MSI. So this is it's quite good. It has a lot of USB ports, and as I said, it has wireless LAN as well. So this for me, this is a must. There are some other options, but I would say this is the thing here. Then memory. I have selected here 16 gigabytes. Depending, we are $931, so you basically could go up to you could do 32 gigabytes and stay under 1,000 or around 1,000. But for starters, or for beginners, this should be enough. You don't need to go crazy here, and you can always get more. Then a solid state drive. I would not go and buy a HDD right now. So a 500 gigabyte solid state drive, it's $63, and usually when you're starting, you don't have that huge amounts of data, and you just basically a SSD is enough for all the things. Then you could also add another storage like a HDD, a few terabytes HDD, if you want to, or if you need another additional storage space here. Then it's the thing with graphics cards. Initially I had here a NVIDIA GeForce GTX 1060. I changed it to a GTX 1660 Ti. It's because it's a newer version, and I think it has 6 gigabyte storage instead of 4. The thing is, why I choose to go with an NVIDIA card is that every time for the data scientists, if you want to get into the data scientist stuff a bit and do machine learning and do like deep learning on top of a GPU, you need a NVIDIA GPU. And these 1660 Ti's, they're quite decent. They have, let me get here, just on one, continue. How many CUDA cores does that thing have? That thing has, I don't care for the country, I just want to have, it has 1,500 CUDA cores, so this is quite nice for processing. You could also go for a 1060 Ti. 1660. They look like they don't really have those anymore. 1060. It's it depends on which model you get. You can save a bit of money. I think they have some, but they have only 3 gigabytes of storage. So if you want to do GPU processing, you need storage on the GPU, and more or less as much as you can get. So it's advantageous if you have 6 gigabytes. They are also with 6 gigabytes, but there you go, 413 in this case. So I went and thought, okay, let's get back to a 1616 Ti. It's the newest version and it's quite decent. You could go 1060 and save some money, and then just a mid-tower case. Don't go crazy and get a big case, and then a power supply. I would say we have here around 260 watts, and this is a 550 watt power supply. That's fine. That's okay. And I would say this is okay. I'm always, or I would always go for a modular power supply. This is a semi modular. You can get a fully modular, but I don't know if that makes so much sense. So this I think is a decent build for starting with data engineering, starting with machine learning. You have enough power, you have enough memory, storage is okay, GPU is okay. So this is I would say this is enough to start. So this is a $931 build. And then what you could also do is, if you want to have a bit more power and you can spend a bit more money, now let's try to get to that part list. I called it upgrade. System build. No, I'm still on the old one. How do I get there? This one here. So this is an upgrade to that. I would go, in this case, this is a Ryzen 7 2700X. It's a bit of a faster base clock speed, and it has 8 cores. So the other one basically has, with hyperthreading, 12 cores, and this one has 16. So it's power wise, this is even better, and you can run the stuff even faster. And then the same cooler, same motherboard. They have more RAM, two 16 gigabyte slots, is also, I think this is also faster RAM, but the actual clock speed of the RAM is not that crucial here. So funny, crucial. Same name of the SSD. So this would be an upgrade if you say you need 32 gigabytes. Make sure you don't have 8 gigabytes per slot or per how's that called? Per brick. This is a 216 gigabyte, and so more a faster CPU and more RAM, and then I would also go for a faster video card. So this something like a GTX 1070 is quite decent. It's not super cheap, but this is a decent one. You could also go for a 1080, but then you're going, then the price to value ratio is getting worse. So the 1060 is a quite good price value or price speed ratio. This 1070 is also very good. It has 8 gigabytes of RAM, so this is even better if you want to do processing on the card. And same case, and then a stronger power supply. I would say a 750. I would get a 750 watts power supply. Although this thing has 330 watts, maybe you want to change the graphics card to something like a Titan in the future, or some new RDX 2 something, or a faster processor, then you would need more power. So this build is basically 500 or 550 bucks more, or 540 bucks more than the other one. It's basically a more powerful CPU, more powerful GPU, and some more RAM. And I think with this stuff you can really do some damage and have a lot of fun setting up systems and not getting super bogged down and not being able to run multiple tools for data engineering in parallel, and not being able to or having wait for analytics too long or longer. This is a faster system with, I think, still a good price to value. Like this, if you think about it, just a fun. We cannot really compare the Mac to this thing because Macs don't have NVIDIA GPUs. I was. What's with the new Mac? The new Mac. The new iMac. That thing has, how many cores does that thing have? I know. Macs are notoriously expensive. 6 core. This is too slow. That's too slow. 8 core. So you can get a 16 core processor. This thing starts at $2,699. $2,700. Okay, so just for comparison, of course, you're getting a screen and so on, but yeah, I would say this is something that is worth it. This is something that you can very, very much use, and yeah. Okay. Any more questions about this, guys? And then, if you have some, put it in the chat. If not, this recording is going to be online, and I'm going to put the links to the builds in the description, and we can have a discussion about this in tomorrow's chat. I know that today was a bit of a short notice, but yeah, tomorrow is the old schedule. Okay. Thanks for watching. If you're not already subscribed, subscribe to the channel to get more data engineering stuff. And if you hit the notification bell, you will not miss any updates. Yeah, and hit the like button on this one if you like this, and if this stuff helps you get into applying data engineering and data science, or developing for data science. Then short stream today. I was quite busy today and came home quite late. So yeah, that fits. See you tomorrow. Bye bye. Have a great day and a great evening, depending where you are, or a great morning. And then see you today or tomorrow. For me, tomorrow, same time, 10:30 p.m. CET. Oh man, Central Europe time, or 2:30 Pacific Standard Time, PM.